Bentz from T Systems will speak about from CHP to VPP how to create value for all market roles. Andreas is executive consultant for smart grids at the Deutsche Telekom T Systems in Germany.
Yes,
so
thank you very much. Also, a warm good morning from my side to everybody. Well, Linda gave me a brilliant said in terms of the challenges and of course also the complexity of all what is behind smart grids, what is behind smart metering. So I actually can spare to talk a lot about these issues on the right-hand side, mass data handling and all these topics. This is one of the challenges, and of course so it seems that we don't have the right fonts on here, but anyhow, the challenges that you are about to tackle with smart grid technologies on the one hand side, on the generation aggregation, which is generally known as virtual power plants, but also aggregation of load. On the other hand side, of course, as well with the management of distribution networks, distribution automation. First of all, let me share a few words on why here somebody out of the telco industry is standing. And the Magenta T does not stand only for T-Mobile. It stands for Deutsche Telekom Group, which provides on the one hand side, of course, their traditional services like telecommunications, like IT, but it stands also for T Systems, a systems integrator that provides energy industry specific solutions. So we are bundling things together, and what you can expect from a telco is not only telephony lines, is not only SIM cards, but this is what you can expect, like every other customer can expect from a telco. It's service. The customer buys telephony service. So this takes also a little bit out of the complexity that Linda has mentioned, and I would like to share with you a few thoughts on how services can ease up that situation in order to cover the complexity from what you are doing, what you have to do in terms of smart grid, and come to what you need to do, which is managing the energy grid, because this is also a clear statement. We will not go into the energy sector, so we will not compete with you. We want to supply you with the services that are appropriate to do your daily business. First, Linda mentioned it already, the uptake of decentralized generation, of course, poses a quite significant threat on your systems. And you see here on the right-hand side the uptake that we have created in Germany by the heavy subsidizes to photovoltaics. It's not only 5,000 devices installed. We created even situations where this is what utilities told us. Actually, they had to install, or they had to hook up to their systems installations that were facing the northeast direction of a roof, because it was obviously so economic, the subsidy that you can get from the German government here, that it was reasonable to install a photovoltaic system on northeast-bound roofs, because all the southwest-bound roofs were already covered with photovoltaic systems. The threats that are the challenges for the distribution grid that are posed on the distribution grid are, on the one hand side, the heterogeneous environment that is created. So you have a lot of different installations. On the other hand side, the volatility of the generation. So photovoltaic systems especially, but wind also, they are not blowing permanently. The sun is not shining permanently. And of course, the increasing number of active components in the grid is facing another challenge. All in all, the key issues here are flexibility, are of course scalability. The amount of devices are increasing. The smart grid, as of today, is only smart into the medium voltage level, which means the substations, 3,900 in Germany, for example, have to be addressed. In the future, you will have the 600,000 secondary substations, you will have the millions of photovoltaic systems. And of course, if you're talking about millions, then you're talking about economic viability. And of course, you're talking about security, because you go much deeper into the network. In a primary substation, there is still a high voltage on that premises, which might keep at least attackers to crawl over that fence. In a secondary substation, that might already be different, but if you think about hooking up photovoltaic systems, micro CHPs, you are on customer premises. These customers might just out of curiosity play around with these devices. It is a good idea to have a look on eBay, for example, to see whether your control devices are not sold there for feeding that curiosity of people that might try to break in that. So the security threat is increasing here on that part. Coming to the first part, which is the management of decentralized generation and loads, it creates a lot of complexity if you think of the different systems that you have to address here. What do you want to do really with that virtual power plant, with that aggregated generation and with the aggregated loads? First of all, you want to do purchase and schedule optimization. You want to trade perhaps reserve energy with that. You want to do peak shaving, management of your balancing groups, and in Germany, a special case, you want to reduce, for example, the shutdown of photovoltaic systems, because in Germany you are required to reimburse the owner of that system for that electricity that he could not sell. So these are practically use cases for a virtual power plant. And in order to take out the complexity outside, okay, here we are with the next slide. Just one example for one of these use cases, of course, one of the most obvious ones is peak shaving. If you can achieve, for example, that the load peaks that you have here in this case with the capacity of a virtual power plant that you have and cut these peaks. These are only a couple of minor peaks over a day or over a monthly period, but they, of course, can significantly increase your acquisition cost of energy. So cutting these tiny peaks here, first of all, identifying these peaks, and then afterwards cutting these peaks can actually make a whole lot of sense. Can I have the next slide, please? Okay. I think this works better than the presenter here. So taking out the complexity out of that whole game means that on the one hand side, you need to address these devices, you need the operational parameters, you need the consumption, and you need the generation, of course, of these devices, of the renewables. This is practically the task of a metering platform. This is an additional task of metering services that you can use. Then the next part that you need is a kind of prognosis step here. So taking all that data into consideration, adding weather information, adding price information for gas, for electricity, it creates a prognosis where you actively see what is going on the next day, or even if you go to intraday, if you want to go into real-time pricing situations, you can actually do this as well on an intraday base, so you get a prognosis of what's going on in your energy system the next 2, 4, 6, 8 hours. And of course, you will then need an optimization of that situation. So for example, if you figure out that within the next 6 hours you will approach a load peak, then you can of course think first of all, well, we have a virtual power plant here, so we have distributed generation. I just raise that generation, but it might be that the gas price, because these micro CHPs are usually gas driven, the gas price is high, so it doesn't make so much sense to utilize gas On the other hand side, you can use demand side management, lower the loads that you have, and create an optimal, an economic optimal situation out of that. Okay, this is here a complete software suite with all what Linda pointed out, all the versioning, all these things that have to work end to end. Of course, it has to work end to end also through a control mechanism, which again could be a reutilization of a metering platform that you have, because you have already communication into the household where this virtual power, this device sits. Let it be a heat pump as a time shiftable load, or let it be a micro CHP. But as we said already, a lot of complexity in there. We want to take out now the complexity. Take out the complexity by encapsulating this software here into a what we call cloud service. This means that you can actually generate all this out of a cloud. You don't have to worry about the versioning, the interaction of all of these components, because you buy this use case, or one of the use cases that I pointed out, as a service. Being operated within a data center and purchased, of course, not a 100% solution. These 5 use cases might serve only 80% of your needs, but on the other hand side, it takes out a lot of the complexity of operating such a system. Of course, the world is not as simple. We're still facing a lot of challenges in the field of virtual power plants. On the one hand side, of course, definitely the communication. We would love to have standardized interfaces to the devices. In fact, we don't have them right now. We are addressing that with our metering solution by just adding the flexibility through a driver system, through an intelligent device that is located on premises. But of course, standardized interfaces would make a lot of sense here. It would create economics in mass markets. Security and data privacy is, of course, a very important issue here. The discussion is centralized versus decentralized models. I wouldn't see that as a versus. I would see this as an and, because it will be probably microgrids that would organize themselves, as well as centrally organized virtual power plants. A very important point is the data exchange of the retailer with the market role DSO, or the market role of the virtual power plant operator with the DSO, because this is at present not possible in real time. You have different market roles, different systems that have to talk in real time. Telecommunications industries have solved these problems already. You might remember the times when it was not possible to use a prepaid phone abroad. It was only possible when these market roles were able to interchange information, to use a brokerage platform for that information in real time, because the operator of your the network operator where you have booked in your prepaid phone, of course, needs the real-time information from your service provider, how much money you still have in terms of credits. So if that is not available upon the push of the green button, it perfectly doesn't work. This worked only with the establishment of real-time clearing houses between mobile operators, which was about in 2003. So this is a solution that is available, talking between different market roles in real time, but it has to be applied here in that market probably as well. Coming to the other field of distribution automation, we are talking here about smart grids. The grids are already smart. They are smart up to the medium voltage level, because the substations are usually already monitored. They are controlled out of the SCADA system. And the blind spot is the low voltage area. The low voltage area has, of course, the meters inside, but these meters are not connected so far. Smart metering doesn't do the trick also, because the smart metering, actually, the information goes into the EDM system, not into the SCADA system. Now, the situation is, as we know, getting more complex. we have photovoltaic systems here, so they create something here in the low voltage network, negative load flows, reverse load flows, everything that has been said by Linda already. So what is the reaction of the utilities? They do practically the same like they do in the substations, also with the secondary substations. They do at least a type of monitoring, which is in some cases also doing some control with the secondary substation, but the situation is getting worse. You have decentral generation out of micro CHPs, you have heat pumps in the houses, and you practically at the substation level do not notice anymore if you have trouble on that part, because the generation that takes place here is eaten up here already. So in parts of your distribution network you can see trouble, you can face trouble that you do not see here at the secondary substation level. So you have a lot of information that you need to aggregate out of the household level, and of course you cannot put all that information into your SCADA system. You need some aggregation in between, but still it creates a whole lot of data that goes into your SCADA system, which can then of course go back into the control of the secondary substation. But what if one of the additional advantages is that you can also get metering information into that system and also place that into the SCADA system. But what if now that information is only needed here in the secondary substation? It would be a good idea not to throw everything at the SCADA system, but use the information that is only needed here on the secondary substation side here and route it to that secondary substation. This would significantly decrease the amount of information that goes to the SCADA system. Of course, you will still need some control and monitoring from the SCADA side, but you have a kind of cycle here generated that actually only cries for help out of the secondary substation if the secondary substation cannot cover this problem that it approaches here on its own. This is what we call a smart data hub. It includes intelligent substations. It includes a kind of distributed intelligence out of the SCADA system, getting SCADA tasks into the local substation level, and of course you need a secure communication to achieve that. Secure communication, of course, is something that we can provide as a telecommunications operator, but you need a whole lot of more here. You need a role management, a rights management, because you are talking here between different market roles, of course. And this is what we try, and now I'm talking about a real-life installation. This is a pilot project that we carry out together with a partner ABB and with the utility EnBW ODR. EnBW ODR has such a network where they already have a negative load flow out of their secondary substations practically most time of the day, because the amount of peak generation has already risen beyond the peak consumption in that distribution network. So what we're doing here is we're facing the voltage and frequency stability with an intelligent substation, which is provided by ABB. They have a voltage regulator in there, which is created out of power electronics, which is not just by a kind of stage mechanism so that you have distinct stages of voltage. You can here regulate the voltage in a much smoother way. But what you need is the information that is generated out of the photovoltaic systems. This is not the generation information. This is voltage and frequency information. So not what you get regularly out of a metering service, or out of a metering system, but you need here additional information. The smart meters create that information, but your metering system should be able to provide that. We developed here a metering service that actually presents that data not on the EDM side, but on the SCADA side. So we are routing part of that information into the SCADA system, and the rest of the information goes directly here into the local substation. again, we have some challenges: communication, protocols, field bus, wide area network in substations. We have the question of distributed intelligence, how much intelligence has to go from the SCADA system into the secondary substation. And of course, again, the data exchange between suppliers and new market roles and grid operators, a problem that has to be tackled in general. As I pointed out already, this is something that has been solved already in the area of telecommunication. This is also one of the hints that might help you if you go back to your utilities and actually think of how you can solve the challenges of smart grids, that there are people there that have already solved these problems in their history, and that are willing to share that knowledge with you in order to help you with that future challenge. This concludes my presentation. I'd like to thank you, and I would recommend to charge this device. Thanks a lot.
Thank you very much. Thank you very much, Andreas. Any questions from the floor? There's a question there on the back. Just 1 second, please. The microphone is coming. Okay.
Good morning. Thank you very much for taking the question. I'm intrigued by the cloud service in mission-critical applications such as network management. How can you ensure the security of that?
Well, the security, handling data in a secure way is nothing that is really new to us, because we have also these mission-critical applications. We have these mission-critical communication lines, and of course, we spend a lot of time in securing that communication, also in the services that we provide to utilities. So, for example, in these communications, we do not only use designated networks for that purpose, so it's not the classical internet as you know it, but we have networks there created, separated that via specific address spaces with non-routable addresses on the one hand, but a separate network doesn't do the trick. Practically, the Iranian nuclear plant thought as well before Stuxnet that having a separate network would do the simple trick. So what we added on top of that are additional layers of defense. On the one hand side, for example, the handshaking of each network node, so with specific credentials. So if these network nodes are not capable to show each other their passport, then simply the network nodes would not be allowed to speak with each other. So if you have then a certificate-based security based on that layer, you also can enter the field of encryption of data. So also the encryption of the payload, even if you are on a separate network, makes perfect sense, because if you have somebody in your network and he can read that data in clear text, this would be as well a method of attack. So there is a multiple layer security applied to these services, which is practically our day-to-day business, but of course it, as Linda pointed out, poses a lot of complexity, which we like to take out of the equation by offering this whole thing as a service. But of course we are open to prove that, because all these security is based on open standards that have been extensively discussed in telecommunications, and the learning curve would be that you do not have these extensive talks also in the utilities, but adapt to things that in other industries have already being discussed.
Okay, thank you very much, Andreas. So let me quickly check if our next speaker is here. Wille Sivola.